Okay, let's try one where we're not entirely sure which direction it's going to go. So a question like this might ask you to find the overall cell potential and also to draw a diagram of this particular cell. So the first thing we want to do is find out what these reactions potentials are. And so we have two of them. We have Cr2O7, 2 minus plus 14H. Plus 6 electrons yields. Make this a little smaller. Some room here. Yields 2 Cr3 plus and 7H2O. So what we're going to do is we're going to look for the reduction potential for this particular reaction. And according to the table, look at that. It's right here. This has a cell potential of 1.33 volts. Here's another reaction, and this is H2O2 plus 2H plus 2 electrons yields 2H2O. And let's get the cell potential of this half reaction. And it is, well, this is the hard part sometimes, is tracking these down, but it usually pops out as pretty easy. H2O2, where is H2O2? Bingo, right here at the top. That has a cell potential of 1.78. Okay, so we want to determine which of these two reactions is the cathode and which is the anode. Let's remember the anode is the source of electrons and that the cathode is where the electrons are going. Okay? So what we want is to find out which of these we're going to run backwards. And let's remember that when we are calculating the cell potential, E cell, is equal to the E cathode minus E of the anode. And that means then we want the overall value that has the most positive, the highest positive value. So we've got a couple ways that we could do this. So remember that what we're going to do is we're going to flip the sign of the anode and add them together. We got two ways we could do this. We could make this our cathode. And so that would be E cell would be 1.33. And we are going to flip the other one, which would be this guy, make it negative, and add that here. So when we do that, we're simply going to take these two, we add them together. Hang on. I didn't have my calculator ready, everybody. I'm sorry. Go get a snack. Okay, 1.33 minus 1.78, and this is negative 0.45. That's if we make this the anode. The other way we could do it is if we make this the cathode and make that the anode and flip that one. So that would look like this. E cell is going to equal 1.78 minus, I'm sorry, we're going to add minus 1.33. And you don't really even need a calculator if you've already done the first one, because you're going to get a very similar answer, but let's do it just because. 1.78 plus negative 1.33, and we get 0.45. So we want the most positive value, and that's going to be this guy. That means this is going to be our anode. So let's make this the anode and this the cathode. So we're going to run this reaction backwards. Okay, this gets kind of tricky, so you want to be careful. So if we were going to run this backwards, this would look like this, and my memory is not very good because this quarantine has got me kind of stupid. So let me make this smaller so I can see them both. So flipping it backwards, we'll make our anode 7H2O plus 2Cr 3 plus yields 6 electrons plus 14H plus and Cr2O7 2 minus. The other one, which we are not going to run backwards, is going to be our cathode, and this is going to be where the electrons are going, H2O2 plus 2H plus 2 electrons yields 2H2O. Now you want to get a balanced equation for this, and that means that we're going to need to multiply this whole thing by 3. So now our cathode reaction is 3H2O2 plus 6H plus 6 electrons yields 6H2O. Well, let's combine these and we can get our balanced equation, and then we can draw our galvanic cell. And we want to cancel out stuff that appears on both sides. So 7H2O plus 2Cr3 plus 3H2O2 plus 6H plus and 6 electrons yields 6 electrons plus 14H plus Cr2O7 2 minus plus 6H2O. Okay, so we'll cancel out the stuff that appears on both sides. That gets rid of our H2Os on both sides. We have 1 left here. Our electrons are gone. And 6 H pluses and 8 H pluses are left over here. Okay? So overall equation is going to look like this. H2O plus 2Cr3 plus 3H2O2 yields 8H plus. We've got a Cr2O7 2 minus, and I believe that takes care of it. So let's double check. We've got 8 hydrogens on this side, 8 hydrogens on this side, 2 chromiums, 7 oxygens, and 7 oxygens. So we're in good shape. So here is our balanced equation. We have calculated that our cell potential is 0.45. And so our overall cell looks like this. And so if we were going to construct a cell diagram, this one's going to be a little tricky because there aren't any solid metals to use as electrodes. So here's how we'll do this one. Obviously, water doesn't really play too much of a part in it, and neither does this, because these solutions are going to take place in water anyway. So if we were going to draw a simple cell diagram, remember that the anode goes on the left. Our anode is our Cr2O7, right? We did that, so that's going to go on the left. So we'll say that in our cell diagram, Cr2O7 2 minus will go here. Since there's no solid metal to make as an electrode, we'll just use platinum, and we'll include the Cr3 plus in our other solution. On the other side, we'll simply have our water. Doesn't really make too much sense, but this is going to be our cathode, which we have proven where the electrons are going is our hydrogen peroxide, H2O2, and so we'll just use H2O2, and they're both in solution, so we don't need to write that, but we'll include our H plus over there just to give it something to bounce off of, and we'll make our electrode platinum. So here is our cell diagram. The electrons are going from the anode side to the cathode side. All right, so give it a try. See you all next time.